Now that we got some idea about how to work with the C programming language, I wanted to give you a quick glimpse of what is it that we will be exploring in the C language as part of this particular course. Okay, so the language itself, right? It was created in the early 1970s. That's a long time back, for specifically for the purpose of creating an operating system called as a Unix operating system. I'm sure all of you would have heard of the Linux operating system, which is essentially coming from the same family of operating systems, which is based on the Unix operating system. Now, the moment I say it was used for creating the Unix operating system, you can imagine operating system itself is an incredibly complex piece of software. So which means that to create such a complex piece of software, the language needs to be equally powerful. Just keep that in mind, right? So we also said that, C language is a compiled programming language. We saw the life cycle of a typical C program. And the C language was originally designed keeping in mind that it has to be highly portable across a variety of hardware and computer architecture processors. Okay, so which means that it was very important to make sure that it is easy to create a compiler, because only if you have a compiler you can convert the high-level language into a low-level language which can run. Now, operating system itself is a piece of software. So if you want that software to run across different processor architectures, I need to be able to easily create a compiler which is running across these processor architectures. So it is extremely portable. So which means that irrespective of what kind of a hardware you are looking for, the chances of finding a compiler for the C language is very high. The language itself has got lots of very powerful features. One of the most important reasons why people still continue to do C programming and use C programming as part of devices and so on is the very high performance that it gives you. The compilers are efficient enough to be able to generate code which is highly efficient across different sets of processors, right, for the CPUs to execute. And they give incredible amount of low-level control for system-level operations, right? So, for example, if you want to manipulate the memory that is present in a computer, right? So you can do it in a very powerful manner using pointers, right? So C continues to be one of the very few programming languages that are still actively used where you get direct access to the memory using pointers, right? So, for example, Java does not support pointers, does not give you direct access to the memory for their own reasons, which we will not get into right now, but C language can. Similarly, very low-level operations on the hard disk, SSDs and things like that are very, very easily done using C language and the libraries available around the C language. Network programming via sockets, right? So if you want to communicate these days, we rarely have standalone applications, right? So we always have applications which are communicating with each other, right? So even when you open a web browser and type the web address, right? So there is a communication happening between your PC and the server. So that is at a low level facilitated by network programming via sockets and then inter-process communication, right? And so there are lots of very powerful things that can be done. And the good news is that as part of this particular course, right, we will explore many, if not all of these aspects of the C language so that you emerge as a very confident C programmer who is capable of developing very, very powerful applications.